All right, continuing on with our trig ratios. Now we're going to find a trigonometric function values given one value and the quadrant. So I am going to ask you right here, I'm asking you, hey, let's find secant theta if I know what tangent theta is, and I know theta is in quadrant 2. Okay, so we know tangent theta is negative 5/3. And we somehow want to use our trig identities to relate secant and tangent theta together. Well, we have the the trig identity that states tangent squared theta plus 1 equals secant squared theta. So if you're not using the identities that I gave you, that's where I'm getting these from, right on the front page of this video of our lesson. Please do so. So how does this help? Well, right here we were told what tangent theta is. The tangent theta is negative 5/3. So we can take out the tangent and put in negative 5/3, but because this is tangent squared, we're going to square it. We're going to add 1, and that will give us what secant squared is. And I'm doing secant squared because I wanted to come up with an identity that puts tangent and secant together. So negative 5/3 squared is going to be 25/9. I want to add that to 1, so I'm going to write that as a 9/9 fraction, and that is going to equal secant squared of theta. Let's combine my fractions. So we're going to get 34/9 equals secant squared theta. I wasn't asked for secant squared, I was asked for secant. So to find secant, let's go ahead and come up here. To find secant, I am going to have to square root both sides. So I'm going to square root 34/9. I am going to square root secant squared of theta. Square rooting a square root. Yeah, square rooting a square cancels out the square. So then I am going to be left with the square root of 34/3. Now, I don't want both plus and minus. What I'm going to pay attention to is what's going on with tangent in quadrant 2. What we need to remember is, given my Cartesian grids, we know that all students take calculus. Remember, all of my trig functions are positive in the first quadrant. Sine and cosecant are positive in quadrant 3. Tangent, or quadrant 2, tangent is in quadrant 3 with cotangent, and cosine and secant are positive in quadrant 4. Well, we're in quadrant 2. Only sine and cosecant are positive in quadrant 2. That means we want the negative value for secant, because secant is negative in quadrant number 2, because only sine and cosecant are positive. Well, what if I give you the same setup? Tangent theta is still negative 5/3, and we are still in quadrant number 2. Let's find the sine of theta. So somehow, again, I want to come up with an identity that puts sine and sine, what I'm looking for, and tangent, what I'm given, in the same identity. Well, that identity is one that we know. Tangent theta is sine theta over cosine theta. Well, we want to find, let's get sine by itself. So sine theta, I'm going to cross multiply. I'm going to do cosine theta times tangent theta. So cosine theta times tangent theta. I know, why am I? So tangent Oh, you know what? Here's what we're going to do. Yeah. Hold on. Let me pause. All right. So now what we're going to do is we are going to plug in for tangent and cosine. Tangent, we know, is -5/3. Well, how are we going to get cosine of theta? Well, from our last example, if you remember, we found secant theta. We were told secant theta from our last example is -34/3. So cosine is the reciprocal of secant. So we're going to say -3/34, and that's going to be what sine is. So we notice what goes on here is my 3's are going to cancel out. So sine theta is going to be a negative times a negative is a positive. 5/34. Well, we hate radicals on the bottom, so we're going to move that radical to the top, and then we're going to leave the radicand on the bottom. Boom. And because we were in quadrant 2, all students, right there, take calculus. In quadrant number 2, sine is positive, so we're, well, regardless, it came out positive, but make sure your answer is positive. And then our last example for this lesson, number 5. Oh, I just want to remind you, please pay attention when you're doing your sines. Pay attention. Remember which quadrant you're in. So this is the kind of, I got to be honest, I love this stuff. So let's rewrite each expression in terms of sine theta and cosine theta, and then we want to simplify our expression so that we don't have any fractions. All right. So I've already got a cosine theta, so that's just going to stay cosine. So tangent can be rewritten as sine theta over cosine theta. There's tangent. And I am going to multiply that by the cosine of theta. I'm going to put that over 1 just for simplification's sakes. And then what we can see here is cosine and cosine are going to cross out, which leaves me with sine theta. Boom. That one was not bad. Starting off easy. Let's try this one. So we've got cotangent squared theta times 1 plus tangent squared theta. Well, what I'm seeing these squares, and immediately what I think to myself is, wait a minute, do I have a trig identity that deals with this? Or what, do one of my Pythagorean identities deal with this? Well, yeah, 1 plus tangent squared, or we have it written down tangent squared theta plus 1. This becomes secant squared theta. And we're going to bring down our cotangent squared theta, and we're going to multiply them together. Let's write these as both sine and cosine. So cotangent squared theta is cosine squared theta over sine squared theta. Secant squared theta is 1 over cosine squared theta. You can see that the cosines are going to cancel out. And that leaves me with 1 over sine squared theta. Now, sine squared theta by itself is okay. It's not a Pythagorean identity. I really can't do anything with it. But so I've got it down as simplified as a sine or a cosine as it can. But we said no quotients, no fractions. So I'm going to turn this from a sine, since sine's on the bottom, we're going to make it a cosecant squared theta, and that is my final answer. Now, you could have attacked it a different way. And that's okay. That's just the way I chose to attack it. All right, let's hit this up. 1 plus cotangent squared theta over 1 minus cosecant squared theta. But think of our Pythagorean identities again. Our Pythagorean identities right there in the middle of our identities. 1 plus cotangent squared theta. That's going to become cosecant squared theta, making it simpler, want less stuff. And we have 1 minus cosecant squared theta. Well, if we mess around with our Pythagorean identities, what we get is cotangent squared theta. So I have cosecant squared theta over cotangent squared theta. Oh, I'm sorry. This would be a negative because when we move it around, we want 1 minus, yep, that'd be a negative cotangent on that one side. I knew something was tickling my brain that it was wrong. So cosecant squared theta is going to become 1 over sine squared theta over negative cosine squared theta over sine squared theta. So I am dividing with fractions. So again, I'm going to keep the top fraction the same. Multiply by the reciprocal of the bottom fraction. My sine squareds are going to cancel out. And that's going to leave me with negative 1 over cosine squared theta. Cosine squared by itself, I really can't do anything with it, but I don't want a quotient in my answer. No quotients, no fractions. So this is going to become negative secant squared theta. And then our last one, this is getting a little longer than I wanted it to. That's okay. What I am going to do, you know what, why don't we hit this one up in class because it's going to take a little bit. So when we get together in class at our next meeting, we're going to do this with as well as our homework. I do want to remind you as you're doing these, remember when you're working with our trig expressions and our identities, please always write, if I say theta, write theta. For example, we're not going to say sine squared plus cosine squared equals 1. We're going to use our theta, we're going to use our x, whatever we're going to use. Alrighty. So we're going to do example D in class. We'll hit that up. And then I will see you on when I see everybody, and have a great one.